So in this video, I'm going to go over the review for the practice quiz for 6.4. The first question says, in a lab, 220 cells are present at the beginning of an experiment. During the first 9 hours, the number of cells increased by 20% each hour. Write an exponential model giving the number of cells y present t hours after starting the experiment. Estimate the time when the number of cells is 650. So for this one, I want to use the formula A equals P, parentheses 1 plus R to the T. And the reason I'm using plus is because it's increasing. So that's a keyword for going up. 220 is the amount I start off with. This part is not important. It tells me it's going up 20%, so my R is 0.20. Remember, I can take my percent and divide by 100 to turn it into a decimal. So I'm going to do the first part. For my model, I'm going to have y equals 220, parentheses 1 plus 0.20 to the t. So I could combine these together to get y equals 220 to the 1.20 to the t. Then it wants me to estimate the time when the number of cells is 650. So what I want to do is I'm going to go on Desmos and I'm going to graph y equals 650 and the equation up above. So give me a second to pull up Desmos. So I want to start off by typing my first equation. When I type into Desmos, I will need to remember to replace the t with an x because Desmos only works on y and x. And then 650. Then I just want to zoom out until I see these, and I want to see both of my graphs. I want to find where they are intersecting, which my intersection is the x coordinate, so the 5.942. I am going to round for this answer, so about 6 hours. Number 2 tells me my friend deposits $9,000 into an investment account that earns 2.1% annual interest. Find the balance after 11 years when the interest is compounded semi-annually. So for this one, I want to use A equals P, parentheses 1 plus R over N to the NT power. I know this because it says the word compounded, and then it gives me a time frequency. So this is my P, my amount I put in. My interest rate, I want to divide by 100, which gets me 0.021. My time is 11, and semi-annually, remember, is twice a year, and that is my N value. So then I want to go ahead and plug into my formula. So I'm going to have A equals 9,500, 1 plus 0.021 over 2 to the 2 times 11. So I want to go ahead and go back to Desmos to type this in. And when I type it into Desmos, I just start with my stuff on the right side of the equation. So I have the 9,500, parentheses 1 plus 0.021 divided by 2 to the 2 times 11, which gives me 11,954 and 26 cents. I round because that third decimal place is more than 5. So here is my final answer for this. It just wants the, when I type it into Desmos, I'll type it without the comma and without the dollar sign. Number 3 wants me to determine the growth rate for the model. The growth rate is always this, and then remember this is a decimal, so I have 0.4, and I want to multiply by 100 to turn it back into a percent, which will give me 40. Number 4 wants me to simplify my expression, so I can go ahead and rewrite this as 64 over 8 and e to the 5th over e cubed. 64 divided by 8 will give me 8. with my fraction with the base e, I subtract my exponents. So I'm going to really have e to the 5th minus the 3rd, which will just give me 2. So I have 8e squared. This next one wants me to simplify the expression again. I have two things inside with an exponent on the outside. So remember, this 2 has a secret exponent of 1. I'm going to distribute to that. So it's going to be 2 to the 8th. Then I'm going to also distribute the 8 to the e. So it's going to be to negative 9 times 8 is negative 72 to the x. I am going to go to Desmos to see what 2 to the 8 is, which gives us 256. So I have 256 e to the negative 72x. Remember, negative exponents turn it into a fraction. So this is going to give me 256 on the top, and the base with the negative exponent moves to the bottom and turns positive. So this one is this choice. Number 6 wants me to say which exponential function is shown in the graph below. What I can do, there is a fourth choice that is not showing up. Y equals 4e to the 0.5x. I can go ahead and graph my 4 choices on Desmos. So the first one I have is y equals 4 to the e to the negative 0.5x. Oh, and I want to go back home to see this. Then I have y equals just e to the negative 0.5x. I have y equals positive 0.5x. And I have y equals 4e to the 0.5x. So I can immediately tell that my blue and green graphs are not right. So I'm going to turn those off because they are going the wrong direction. If I look closely at this one is crossing through 1. I want to look for which one of those was crossing through 1. That is my red graph. So e to the negative 0.5x. This one wants decay models. Remember, if I have a number in parentheses, I'm looking for bases less than 1. So this one is subtracting. And then if I'm looking at bases of e, it is a negative. So base e, negative exponent. And if it's a number base, less than 1. And these are for decay. If it was for growth, it would be a positive exponent and more than 1. Number 8 wants me to rewrite in log form. This is going to be log base 50. And then the exponent is going to switch spots with the answer. So it's going to be 0.02 equals negative 1. This is my first option here. This one wants me to, again, rewrite in log form. So I'm going to have log base 7, and then I'm going to switch the answer and the exponent. So this one is this choice. Number 10 wants me to evaluate the log. I am going to do this on Desmos, but remember the way to do this is I want to do log 512 divided by log of 1/8. Remember, this is because I have the fraction base right here. So let's go to Desmos. This will give me negative 3. Number 11 is again evaluating the log. I can type this one exactly into Desmos. So I had log base 64. Remember, to get to the base, I do shift and then the underscore key next to the 0. This one gives me a decimal. To turn it back into a fraction, I click the square over square button here, which turns it into 1/3. So this one wanted mine as a reduced fraction, 1/3. Number 12 wants me to simplify this expression. So I again can go to Desmos. I have 10 to the log 9. Oh, I didn't even type that in. 10 to the log 9, which gives me just 9. Just for future reference, whenever I have a base 10 and the word log, those will cancel out, and whatever is left over is my answer. So that 9 was my answer. Number 13 wants me to match up with inverse functions. To find the inverse functions, what I'm going to do is I am actually going to work with the inverses and match up to the function, because I find it easier to go from logs to exponential. So on this one, I raised them both to 8, and I would switch the x and y. So I have 8 to the x equals, on my right side, this cancels out, and I just have y plus 7. So to get the y alone, I would subtract 7 on both sides. I get 8 to the x minus 7 equals y. This one is one of my choices, so this one goes with h. I'm going to do the same thing for b. This is 7. So over here, I switch my x and y. Then I have 7 to the x. The log base and 7 will cancel out. And I'll have y plus 8. I want to go ahead and subtract 8 on both sides. This one gets me 7 to the x minus 8 equals y. That's not any of my choices. Same thing for c. Raise to the exponent of 7 and switch my x and y. So I have 7 to the x. The base and log 7 cancel out, so then I get y minus 8. I want to go ahead and add 8 to both sides, which gets me 7 to the x plus 8 equals y. This is the g function. And then I want to do the same thing for d. I'm going to raise them both to 8. Cancels out over here. Switch the x and the y. I have 8 to the x equals y minus 7. I want to add 7 to both sides. 8x plus 7 gives me y. So this one is D. Number 14 says, biologists have found the length L of an alligator in inches is related to the weight W of alligator in pounds, according to the function below. It wants me to answer the following. It wants me to first graph the function and estimate the weight of an alligator that is 11 feet or 132 inches, round to the nearest pound. So what I'm going to do is I am going to rewrite this as y equals 27.1 ln of x, in parentheses, minus 32.8. Then for number 1, it wants me to estimate the weight of the alligator that's 11 feet. Remember, length was my y, so I'm going to have another equation, y equals 132. So just like on our first problem, I'm going to go ahead and graph both of these and say where they cross. So I had y equals 27.1 ln x minus 32.8. And then over here, I have y equals 132. And I want to see where these two cross. So I scroll out. So it wants me to round to the nearest pound. This is my x value. It is going to be approximately 438 pounds. Number 2 wants me to estimate the length of an alligator weighing 170 pounds. So for this one, I can plug 170 in for my x. Because remember, pounds was the x value. If I go ahead and change those letters up there. So then I go ahead, and this time I'm just using Desmos as a calculator. 27.1 ln 170 minus 32.8. This one wants me again to round in the nearest inch, so 106 inches. Number 3 tells me the x-intercept of this function is approximately 3.40. Describe the meaning in the context of this model. So remember, x was our weight and y was our length. This means that all alligators weigh at least, right? Alligator? Yep. At least 3.4 pounds. Okay. Number 15 wants me to write a rule for G, just by the transformations on the graph of G. It's telling me it has a vertical stretch of 2, followed by a translation 3 units up. So remember, vertical stretches multiply the entire equation. So I have G of x equals So I'm going to multiply this all by 2. The 2 is going to distribute to the e. So I have 2e to the x plus 1. And then it's also going to distribute to the negative 4 at the end to turn it into negative 8. This is still my first step. Then for my second step, it is going 3 units up. Remember, up and down gets added to the outside of the function. So I want to add 3 to the end. Then I want to actually go ahead and combine those two outside numbers to get this. Now what it wants me to do is plug in my values for A, H, and K. This should actually say minus H plus K at the end. This will be fixed when you guys take it. Okay. So A is the same as it is right here, so just the 2. Minus H is opposite the sign, so opposite of positive 1 is negative 1. And then K is the same sign, so negative 5. This one tells me the slope S of a beach is a function of the average diameter in millimeter of the sand particles on the beach. And it gives me this equation, S equals 0.159 plus 0.118 log D. So S is Y, D is X. So I'm going to replace these with Y and X. Then it wants me to answer the questions. Describe the transformations of the function compared to f of x equals log. So I'm comparing these two. It has a vertical shrink of 0.118. I got this from the decimal out front. It's less than 1. And a shift up, because this, remember, could just be moved and put at the end. So a shift up of 0.159. It wants me to determine the slope of a beach with extra coarse sand. So for number 2, I am just going to plug this in. I'm going to have the 0.159 plus 0.118 log 0.9. Then I want to go ahead and type this into Desmos. Which gives me, it wants 2 decimal places, so it's going to be 0.15. And this part is my answer. This is just me numbering. My final question tells me the amount in grams of 300 grams of plutonium-239 that remains after T years can be modeled in the situation. Number 1 wants me to describe the domain and range of the function. So I can rewrite this as y equals 300, 0.9997 to the x. If I go ahead, I can go graph this to see my domain and range. Y equals, right? Yeah, there was 4 nines there. I wanted to change this was. So this one, if I look at it, it looks like it's a flat line, but it's actually going up the more I go to the right. Just kidding, it's going down because this is less than 1. So my domain, I can plug in any x value I want. Domain is all real numbers. Range is y is less than or equal to 300, and this is because it's going down. Remember, to get this less than symbol, I can go into here, the square root of x option. I think it has the 3 dots originally on Desmos. I click that, and then I click on this, and then I can do the less than or equal to. Number 2 wants me to figure out how much plutonium is left after 12,000 years and to round to 2 decimals. So I am going to plug in 12,000. Oops. So that gives me, it wants me to round to 2 decimal places, 209.30.